Hi, welcome to this quick how to help video. We are now looking at indices in the kind of higher GCSE. So we're looking at it at a higher level now, where we've got the fractions, combined negatives, and we've also got something that looks a little bit different here. So we're going to go through these one by one and make sure we understand what each of them is asking of us. So the first question then. 25 raised to the power of a half. Now, any fraction, so that means all of these that we see here follow the same pattern, where the denominator is your root and your numerator is your power. So what we are actually going to be doing, and I always do them in that order, is we are going to root the 25. Now, because the number is a 2, it's a square root. So I'm going to do the square root of 25, which is 5, and then raise to the power of 1. Doesn't actually do anything to it at all. So it just gives me a result of 5. Now, that could be argued it's plus or minus 5. I'm just going to write the positives down throughout this video. This is a really important concept, especially if you are planning on going to study at a higher level with your A-levels, knowing actually that a half power is the same as a square root is really good when it comes to manipulating certain expressions. So a useful one to be aware of. So we root with the denominator and we power the numerator. So if we follow that, and don't deviate from that, then this is going to do the exact same thing. The difference, however, is I have a 4, not a 2. So it's not a square root. It's going to be the 4th root. So it would look like that. And I'm looking for a number that multiplied by itself 4 times would give me 81. And that is 3. 3 times 3 times 3 times 3 is 81. I'm then going to take my result and raise it by the power 3, because the numerator is my power, and that would give me a final answer of 27. So root by whatever order you've been given, and then power. So let's look at the next question. There's an additional problem here. I do that at the very end. So I literally go root, power, reciprocal. Okay. So I'm going to be doing a cubed root, which is going to give me 2. I'm going to raise that to the power of 2, which is going to give me 4. So I've dealt with the 2, I've dealt with the 3, but I still have this kind of negative that I haven't done anything with. That negative is actually the reciprocal. So I'm now going to finish it off by putting the 4 under the 1. And that is the answer to that one. Okay, next question. We do see this and go into a little bit of a panic sometimes. It just feels so much harder, but you are not doing anything differently. You are going to root, and it's a cube root in this case, your 27 over 8. Cube root of 27 is 3, and of 8 is 2. And then you're going to raise this to the power of 2. 3 squared is 9, and 2 squared is 4. And that would be your final answer there. So you are treating the denominator and numerator here in exactly the same way. They have the same acting on them with what's going on outside here. Okay. All right, let's take a look at this last one. These types of questions can come in all sorts of guises. So, I mean, there's so many I could have chosen. They all kind of work on the same principle, and that is that they're giving you something that is different in the base numbers. But the base numbers are connected. So 27 is my base number here. 3 is my base number here. but they do connect by powers. And that's the thing to look for, because that's the thing that they kind of set up in the problem solving. So 9 times out of 10, that is going to be your kind of quick in to the problem. This sounds more complicated because of the terminology as well. So you're expressing 27 to the power of 2x plus 1 in the form of 3y, where y is in terms of x. And all of that can sometimes be a bit too much to take in one go. What they're really trying to do here is say that y is just a representation of something similar to this. Your y, once you have completed this, will actually turn into looking like a piece of algebra with an x in it. So let's take a look at the base numbers first of all. 27, I have got to get to base 3. I need my bases to be the same if I'm able to use any of my power rules. So to get 27 to be 3, I need to take my 3 and raise it to the power 3. 3 times 3 times 3 is 27. So this is now equal to each other. So let's change it and say, that's the fact there. 27 is actually equal to 3 to the power of 3. So if I now say I've got 27 to the power of 2x plus 1, I have 3 to the 3 to 2x plus 1. Now remember, a power to a power has a multiplication rule. So I'm going to be multiplying these. So 3 times 2x plus 1 is going to give me 6x plus 3. So I've now got 3 to the 6x plus 3. So 27, 2x plus 1 is equal to 3, 6x plus 3. Okay, like I say, they can come in lots and lots of different ways. If you've got one that you're not sure about and you want to link it into any comments below, then I will give you obviously some hints and tips and ideas of why it's different to what you've just seen here. All right, I hope it's been a useful video and hopefully you'll be joining me for more in the future.